Hi, I'm Des Model G6WCX. I'm going to be talking to you today about the basic transmitter. Let's start by taking a look at the signals used in the block diagram. Speech signals range from 300 Hz to 3 kHz in a normal communication system. The carrier frequency will be the frequency the transmitter finally transmits on, and is usually above 30 kHz. There are two modulation types we could use in this configuration: amplitude modulation and frequency modulation. Amplitude modulation is where the carrier amplitude is varied with the modulation signal or the speech signal. Frequency modulation is where the carrier frequency is varied with the modulation signal or speech signal. Okay, let's take a look at the block diagram and see what each of the blocks do. The microphone takes acoustic signals, converts them to small electrical signals, which are passed to an audio amplifier known as a microphone amplifier. An amplified version of the microphone signal is then passed to the modulator, along with the carrier, which is generated by the frequency generator or oscillator. This will determine the frequency that the transmitter finally transmits on. The output of the modulator is the carrier with the modulation or speech signal superimposed on it. This is then passed to an RF power amplifier, which produces a high level signal which is passed to an aerial where it is radiated or transmitted. Okay, let's have a look what the signals look like in and out of the blocks. For the demonstration, I'm going to use an oscilloscope to show you what the signals look like. I'm going to be using a 1 kHz tone as my microphone signal, and I'll be using a 30 kHz carrier for the demonstration. The oscilloscope is showing the 1 kHz microphone signal out of the microphone as a yellow trace, and the blue trace is showing the amplified signal after the microphone amplifier. The oscilloscope has been reconnected to show the signals throughout the transmitter. The yellow trace shows the 1 kHz tone from the microphone. The blue trace shows the carrier being generated by a frequency generator or oscillator. The pink trace is the output of the modulator, which is the carrier with the audio or microphone signal superimposed on it. This is amplitude modulation. The green trace shows an amplified version of the modulated signal, which is then passed to the antenna for transmission. Let's see what happens when we adjust the mic gain on the transmitter. As I adjust the mic gain down, the amplitude of the modulation becomes smaller until I just transmit carrier. As I increase the mic gain, the modulation becomes much higher again until it reaches 100%. Any increase in mic gain above this point will cause overmodulation and distortion. This can be seen by the carrier missing between the envelopes. This will cause distortion on your transmission and should be avoided. The final thing I'd like to show you is a real speech signal going through the transmitter. The oscilloscope will show me calling CQ. This completes my demonstration of the basic transmitter and amplitude modulation. If you have any comments or suggestions, please leave them in the box below. Thanks for watching.